The carrier aggregation technology allows operators to combine non-contiguous frequency bands and spectrums to form higher bandwidth and higher throughput to offer to their customers. What we are showing here today is a demonstration of our carrier aggregation technology. Let me go over the setup of the demo system. Here we have a Transcede 2200 SoC femto evaluation module. The device, the T2200 device, is this small device under the fan here. This evaluation module has a radio daughter card that has two radios. The first radio is configured to operate on band 7 at 2.6 gigahertz. The second radio is configured to operate on band 13 at 700 megahertz. So the EVM is connected through a Ethernet switch to a computer which is basically emulating a core network. The core network emulator consists of three modules: a packet gateway, a serving gateway, or SGW, and a third module called MME. So this core network emulator allows us to attach UEs to the eNode B and allows us to generate traffic and hence show the carrier aggregation performance. Here we have radio 1, which is operating at band 7, connected via RF cables to a UE. It is a USB dongle made by Huawei operating at band 7. The second UE that we have here is connected to the second radio operating at band 13, connected via RF cables to this HTC Android phone. Both of these UEs are attached via USB connectors to this computer, which allows us to display the throughput that we are able to sustain to each one of the UEs. Now, in order to generate traffic to the UEs, we're going to use a third laptop. We call it Packet Data Network, or a PDN, to start two sessions of iPerf program and generate traffic to each one of the UEs. Here we have one of the sessions of iPerf generating a stream of data, a UDP data, at 50 megabits per second being sent to UE number 1. And then a second instance of the iPerf program generating a second stream of 50 megabits being sent to the second UE. So on this laptop, we are able to see the throughput as reported by the iPerf program to each one of the UEs. This display behind me is connected to this laptop, so it's easier to see the results on the larger display. This iPerf session here shows the throughput of the UE number 1, and this second session here shows the throughput of the iPerf UDP packets to UE number 2. We programmed the iPerf servers to generate 50 megabits, slightly over 50 megabits to each one of the UEs. So here you can see 50.5 to 51 megabits being sent to UE number 1, and similarly 50.5 to 50.5 megabits being sent to UE number 2. Here we also have another application called net per sec that allows us to show the aggregate throughput of the two UEs combined together. The bar graph here shows the throughput of the combined UEs, or the aggregate throughput of 103 megabits per second, or slightly over 100 megabits per second. The second box here shows the average throughput, and the third box here shows the maximum throughput which was received during this session. In order to show that this is a live demo that we are running here today, I'm going to stop the data streams one at a time and see the throughput going down to 0, and then turning them back on, going up to over 100 megabits per second again. So here we have stream number 1 stopped, going to UE number 1. You can see that the aggregate throughput fell down to slightly over 50 megabits. And now I'm going to stop the data stream going to UE number 2. You can see that throughput is now all the way down to 0. The average is being reduced all the way down to 0. And now by turning back on the two throughputs, we should see a aggregated throughput of over 100 megabits per second again. Here I turned on the iPerf traffics again. When I turned the first one on, you could see that the throughput went up to 50 megabits, slightly over 50 megabits per second. And then by turning the second one, the aggregate throughput went up to over 100 megabits per second. In conclusion, I would like to highlight a few items about this new PHY, which was designed to be Release 10 compliant. Even though we do not currently have any Release 10 UEs available to us, the PHY was designed to support Release 10. In this demo, we are using 2 Release 8 UEs to prove the functionality of the PHY to over 100 megabits per second. It is important to highlight that the PHY currently will support both interband and intraband operation. The PHY is independent of the frequency bands, and it can support any frequency band as limited by the radio and the hardware. And also, I would like to highlight that this is an alpha version of the current PHY. And the next step would be to improve the throughput to 150 megabits per second and show full duplex operation.